So, if we know, what do you know about a quadrilateral? Talia? It has 4 sides. So a 4-sided shape. What are some quadrilaterals that you know? Drew? What are some quadrilaterals you know? Some 4-sided shapes.
Oh, 4-sided shapes.
Give me a shape that has 4 sides. Sure. Garrett?
Like a part of somebody's glasses, like for what you use it.
So give me the name of the shape.
Like this? Where?
Sure.
Like that?
A square. Thank you. We really need to stretch our thinking here. Lucy? A polygon, yes. A polygon is any any shape that has more than 3 sides, and those sides all have to be straight. There are no curved sides. Talia? Okay.
Diamonds are 4 sides. For angles and for vertices.
Yeah, there's a fancy word for a diamond.
It's called a rhombus. Oh, rhombus.
A rhombus. And we might know one more. Bryson? Trapezoid. So I'm saying that quadrilaterals are any 4-sided shape with 4 sides. And it makes like an umbrella. Underneath the umbrella of the quadrilateral, we have names for other shapes. So these shapes all have, they all have 4 sides, but they're all different. So today we're going to look at how to classify them, how to organize them, looking at other parts of the shape, not just the sides or the number of sides.
Yeah.
So, what could we be looking at if we're not just looking at the number of sides? Olivia, come and join us. It's okay. Just leave that there and come and join us. So think about what we've talked about yesterday. Levi?
The number of vertices.
Ah, the number of vertices. If we have 4 sides, how many vertices are there going to be? 4, yes. But yes, we can look at the vertices. What's another word? What do we find in the vertices? The angles. So we could be looking at the angles. We can look at the angles. What else can we look at? Sophie?
The sides.
The sides. What could we look at the sides?
If they're parallel.
Yeah, if they're parallel. So we could look at if the sides are parallel or not. Some shapes have 2 parallel lines. Some quadrilaterals have 1 set of parallel lines. Okay? Mr. Powell, I've got some things for you.
Thank you.
Okay, so just to recap, we talked about we're going to look at angles, and we're going to look at whether the sides are parallel, how many parallel sides it has. Right now we know a square has 2 sets of parallel lines from our work yesterday. And we can also look at the sides. I'm going to give you a little clue. I'm going to give you a clue. We can look at the sides, and I want you to tell me what we can be looking at when we're looking at the sides. And here is an example. A square and a rectangle. What can you look at the sides with your square and your rectangle? Don't fight me. This is a fair question, and I'm concerned that I just have 2 hands up.
What was the question again?
Levi?
That the rectangle's longer.
Okay, so what are you noticing with the sides?
That they're skinnier.
Yeah, they're different lengths, right?
Yeah.
Okay, so here we go. Now, I have a chart. And in this chart, I'm defining and I'm looking at the different parts of the quadrilateral that make it what it is. So a square. My chart says that all sides are equal in the square and that all of the angles are 90 degrees. What's new there that you aren't sure of? What's the new thinking or new learning there that you're not sure of? Levi?
Angles are 90
90-degree
degrees.
angles. Okay, so let's try to figure that out. Let's try to figure this out. We know where the angles are. So this is telling us that the angles are 90 degrees. So where am I going to be looking in the square to figure out what 90 degrees equals or means? Lucy? At the angles or at the, what's the other word? At the vertices. Okay. So let's look at the vertices. What do you notice? What do you notice with the vertices in the square? And then I want you to compare that with the trapezoid or the parallelogram. Look at the vertices there. How are they the same or how are they different than at the square? I'm asking you to do lots of thinking here. What are you noticing, Bryson?
I'm noticing that on the square, the vertices go like up and then over, but then with the trapezoid, it goes on a curve and over.
Okay. So I'm watching you with your hand. You said that it goes up, and you used your arm, and over. Okay? And in the others, you're noticing that it goes
Like diagonally
and then straight across. Okay. That's a good explanation. So let's look at what Bryson has talked about. This is 90 degrees. And I can show 90 degrees by drawing a little square in the corner. So this is really important. The other angle is smaller than 90 degrees. And I can draw it with showing just a little half arc or a circle. There's some names for this angle. It's smaller than 90 degrees. It's so cute. it's called an acute
Oh, I get it.
angle. It's so cute because it's smaller than 90 degrees. It's acute angle.
Oh, I get it.
Okay? That's a word you don't need to know in grade 3. You need to know that angles are smaller than 90 degrees or angles are bigger than 90 degrees. But Mrs. Duchesne says, oh, your grade 6 teacher is going to thank me forever when you come to grade 6 already knowing what an acute angle is. Because it's easy to remember.
She wants us to learn.
Shh. It's so cute, it's tiny, it's acute.
My brother tells me
Now, I'll wait until our eyes are here again. There's a third type of angle. We have angles that are equal to 90 degrees that I show with a square. I have angles that are smaller than 90 degrees that are so cute. They're acute angles. What do you think the other kind of angle is? Talia?
uncute.
Well, what do you think they would be? What would it look like?
It would be really big one.
Bigger than 90 degrees, you're right. So it looks like that. And I can show it again. I don't show it with a square because that's not a square angle, a 90-degree angle. This is called obtuse. And there's no way of remembering it. It's just obtuse. It's bigger than 90 degrees. Okay, grade 3s. How can I find a 90-degree angle? How can I find a 90-degree angle? What are your thoughts? I almost want to have a tester. What could I use to test to find a 90-degree angle? Evan?
Can I come up?
No, I want you to use your words.
So, if I had a rectangle here and I was trying to find a 90-degree angle, I think you said,
Mhm.
yeah, you could put squares in the corners.
You could. You could. And you know what?
Because then, like, if I had, like, how can I come up?
No. You could use
Squares.
this sheet of paper because it has a square corner.
You could use these.
You could use a pattern block. The orange pattern block is a square. You can put that pattern block in the angle, and if it lines right up, then it is a 90-degree angle. So a 90-degree angle is in all squares. That's what makes it a square. Okay? What about a rectangle? How is a rectangle different than a square? Share your learning. Sophie?
A rectangle and a square, it's different because the rectangle, it's more thinner, and the square, it's more large.
Yeah, what does a square have?
Um,
All sides are Lucy? Equal. So Sophie, all sides are equal in a square, and in a rectangle? They're not equal. Opposite sides are equal. Now, here's our new word. I can add this to my chart. A parallelogram. What do you think a parallelogram is? Makes it a parallelogram and not a square or a rectangle? Garrett?
It's like it's not a square because a square is smaller than it on the board. But
What does a square have that the parallelogram doesn't?
straight sides.
Okay, they all have straight sides. Let's go back to my list. We looked at the sides. Pardon? Yeah, let's look at the angles there. Let's look at the angles in the parallelogram. What do you notice about them?
They're all different.
Yeah, what kind of angles does it have?
Like
What kind of angles does it have?
Acute.
There's, how many acute angles are there?
Two.
Two. And then what are the other angles?
I think it is the square one. That one.
So if I got my tester, okay, let me get my tester. I'm going to put my tester here. And my tester, there's my, see the black line? That's my tester. That's smaller. And there's my tester. That's bigger. So angles that are bigger are called obtuse. So in a parallelogram, there's two acute and two obtuse angles. Opposite sides are parallel. It does not have 90-degree angles. No. So can you give me another word for a parallelogram? If parallelogram was a smaller umbrella, what words would fit there? What if I had it turned?
That's not a rhombus. Yes, it is. Both sides are not equal. Sophia, it's a rhombus.
What shape is that?
Oh, at the bottom.
This
I
one.
thought you meant parallel.
What shape did I just draw? It has two acute angles, two obtuse angles. Opposite sides are parallel. It is also a, this was the grade 2 word you would have used, starts with a D.
Oh.
Lucy? Diamond, thank you. All right, and a trapezoid. What do you notice with a trapezoid? Shh. What do you notice with a trapezoid? Lucy? The top and the bottom are, yeah, they're not equal, but they're also parallel. Yes. Does it have 90-degree angles? No. What kind of angles are in a trapezoid? Obtuse and acute. This line is parallel to that line. They're the same distance apart and they never cross. Because you're going to, if you extend this forever and ever and ever, they're never going to cross. These lines, if you extend forever and ever and ever, they do cross. Okay? And a rhombus has equal sides and opposite sides are parallel. So this side is the same length as this side and it's parallel, and this length is the same length and it's parallel. Lots of learning there. We can add to our chart.
We've got lots of time.
I think it's trying to go somewhere.
Yeah, oh, we have 19 minutes. What? How much minutes do we have? 19. 'Cause that's what I just guessed.
Okay, I don't want to wait any longer. Oh, here we go. Shh, grade 3s. So we've talked about all of those sides. Square, rectangle, parallelogram, trapezoid, rhombus, kite. We don't need to know a kite, so that's okay.
I have a kite.
Okay.
Seriously, I didn't know that. Yes, want me to bring it here? Shoot it.
All right. So our next little discussion that we're going to have with each other, we're going to talk with our elbow partner. And I want you to discuss, convince me, is a square a rectangle? So you're going to chat with your elbow partner and you're going to talk about, is a square a rectangle? Got it? So who can tell me what we're going to be talking about? Bryson?
We're going to talk to our partners and see if the square is a rectangle.
Okay. Anybody not sure what you're talking about? Okay, go.